So let's talk about sketching the graph of our tangent of function over the interval from negative pi to positive pi. Now, why did I choose those? Well, if you think about it, when we've been graphing our secant, cosecant, sine, and cosine functions, we've been going from 0 to 2 pi as just sort of a standard basic unit. But tangent's a little weird in this way. Remember that tangent is a function that passes through uh, uh, the same sort of domain as the secant function. That is, our domain for tangent of x is the set of all x such that x is not equal to odd multiples of pi over 2. So 2n plus 1 multiples of pi over 2 are excluded from the domain of this function. So what that's going to mean for me is this. Let's look at what a cosine function might do here. I'm just going to lightly dash one in here. I hope you don't mind me using yellow. Here's a cosine graph, and each of these marks represents a pi over 2. So what could we say right here? Actually, let me spread that out a little bit here. There we go. Go back to my pen right here. But each of these marks right here represent pi over 2. All right, so one full cycle of cosine might have been written this way if I dash that one in really lightly. Here's what one cycle of cosine would look like on the interval from 0 to 2 pi. And of course, over here going to the left, following the same patterns. Here's, let's see, negative pi, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. So something like this would represent our cosine. All right, so what could we say? Well, anywhere where this is equal to 0, we're going to have a vertical asymptote. So we're going to make a vertical asymptote here at negative pi over 2 and positive pi over 2 and positive 3 pi over 2, not to mention negative 3 pi over 2, and so on. All right, so within each of these intervals right here, we see what's happening. As I go from negative pi over 2 on the left to positive pi over 2 on the right, I see that I'm going to get two vertical asymptotes and something happening in between them. Well, that's where we want to concentrate. If I look at one basic cycle of my tangent function, I know that starting at negative pi over 2, which is one of my vertical asymptotes, and ending it in positive pi over 2, which is another one of my vertical asymptotes, I want to see what's going to happen. Well, what do we know? Tangent of 0 is going to be 0. So we know that this is a kind of function that the tangent of 0 will equal 0. How about pi over 4? Well, we know that the tangent of pi over 4 is equal to positive 1. So here's positive 1. And the tangent of negative pi over 4 will be negative pi over 1. Negative 1, pardon me, because that is a odd function, right? What happens at all these other points? Well, as we get closer and closer to pi over 2, the value of tangent gets larger and larger. And by the way, as we go towards negative pi over 2, the value gets smaller and smaller, tends towards negative infinity. And what's going to happen is that this cycle is going to repeat in every other interval here. So for example, we'll pass through the x-axis at pi. Tangent of pi happens to be 0. The graph will pass through points that come along the vertical asymptote at pi over 2, pass through pi 0, go through our pi over 4 unit, and just head towards that vertical asymptote. And I've had a colleague in the past who characterized this as what they called a wallpaper function, because it looks a little bit like wallpaper, in that when we keep repeating the pattern over and over again, we get this same pattern going along these strips, each one approaching a vertical asymptote as it goes. Well, what kind of things could we characterize on this function? Well, first of all, the vertical asymptotes are occurring at points that correspond to our domain, that is, values like negative 3 pi over 2, positive 3 pi over 2, negative pi over 2, and positive pi over 2. So as we go on with these values, we could just simply say, like we did with our domain, that x is going to be, the vertical asymptotes will occur at any point where we have an odd multiple, a 2n plus 1 multiple of pi over 2. But now there's something even more interesting right here, and that's this. Normally, our period for a function goes from point to point, and for sine and cosine and secant and cosecant, it was always 2 pi. But look at what happens here. The period of a tangent function can be said to go from negative pi over 2 to positive pi over 2, and that period takes a length of pi. So the natural period of pi, or natural period of tangent, is going to be pi. Very interesting. There is no amplitude, right? Because our range goes from negative infinity to positive infinity, so we can say that there is no maximum or minimum value, and so this graph is going to follow along. However, one thing that we could say, it's helpful anyways, is that if you were to draw a line at y equals 1 or at y equals negative 1, you can see that what's going to happen is that 1/4 points within each of those intervals is going to pass through that x-axis right here, for example, at negative pi over 4. We get negative 1. And at positive pi over 4, our quarter point here, we get positive 1. Right? And this is our pattern that we follow right here all the way through. We're getting a positive 1 at 3/4 of the way through each cycle, and negative 1 at 1/4 of the way through. Right? And that pattern repeats itself over and over again. So this is very, very useful for us if we wanted to get a good idea of what this graph is going to look like.